Okay, so today we're gonna talk a little bit about router and switch configuration. I think that we're not gonna dive into Cisco routing and switching until maybe a couple weeks from now. Um, the main reason is that we want to kind of talk about it, and then we'll use Packet Tracer next week. But today you are going to use a small switch, and that's going to give you a little bit better understanding on how we lay configuration on the small switches. So it's a pretty simple like home small business based type of switch. So we're gonna be using these for the lab today. Okay. Um, and we'll introduce some of the commands with Cisco technology and along with if you're using Cisco or if you're using Fortinet, it's kind of the same. I think everybody kind of rely on Cisco or mimic the command line for Cisco. So you see some similarity in some of the other brands. So the first part of the note on the first page, it goes over a little bit of router configuration and how you would be able to access certain type of mode. If you have taken Cisco classes with Riverside City College, you probably are familiar with some of the commands or if you used Packet Tracer before, but we'll get into Packet Tracer next week, okay? So the beginning, it talks about router configuration, and we know that the router is really a way for us to connect one network to the next network, right? It is a gateway for us to be able to have communication from one local area network and get to the gateway, and that's going to transfer your data to the next network. So in Cisco devices, there are multiple modes. Number one is your user exec mode. This is when you first connect the router, and what you see is you see the little arrow symbol. So when you turn your devices on, this mode is read only. That means that you cannot add settings or change the settings or configuration to this particular mode. Basically, it's really good for just display. Like if I wanted to see what the router current configuration right now, this is the mode that I want to be in. I don't want to modify anything. I just want to take a look at what it has, right? So you would see that it would have its name. So by default, it's going to say router until you name it, or switch, right? Until you give it a name. And you're going to see the little arrow symbol. Now, the second mode that you would see is your privilege exec mode. And this is where we can make changes to the actual settings. So when you first turn it on, it's going to be read only, right? That is really to protect the setting for the device because you don't want somebody to go in there and change up everything first off. So when you get into the exec mode, you need to make sure that you type enable. So when we type enable, that allows you to open up this mode so that way you can make some modification like changing the router's name, adding an IP address, maybe enable a certain protocol for the router or set up routes. Now you can also use a shortened command by using en for enable. If I don't want to type out enable as an entire word, I can also type en and it's going to take it as enable. So in order to access the privilege mode, you have to get into enable. And you're going to see this when you actually use the router. You're going to be like, oh, how come I cannot modify the IP address? Well, you have to enable in order to go into a write mode. So basically, that's going to allow you to do a changes or the modification mode. Okay. And then the third mode is your global configuration mode. This allows you to make complete changes to the configuration. So when we turn on the router, it's going to start here. And then I type enable, then it's going to get into the privilege mode. But at that time, I can display some information. I cannot fully configure until I get into the global configuration mode. which is where we need to put in config term. So this third command is going to allow us to make full configuration changes. And once you issue that, it's going to give you the config, right, mode that it would be able to store whatever that you want to make changes. And that gets added to the RAM of the device. Once we're done, we want to save it because otherwise all your configuration will go to waste, right? And then when you want to get out of that mode, you just do an exit. And if you want to return to the first mode where it's read only, you just want to put in disable. And we'll practice some of the command through packet tracer and then along with the actual router or switch. Okay, so let's go through and answer some of the question. For number one, it says, when using Cisco router and managed switch, which mode is used to configure the device and how do you access such mode? So in order to configure the device, we need to go into the global configuration mode. As we mentioned, that's the third mode, right? So when we turn on the router, we would see the router information with the arrow. Then we're going to type in enable, that allows us to get into the privilege mode. Then to get to the third mode, which is the global configuration, we will type in config term. And config term stands for configuration terminal. And that allows you to make changes to the configuration of the device. So this is the same with the Cisco switches for the iOS and also the same with the router. Now, if you're looking at older devices and newer devices, right, if they're using the same operating system, then it would use the same command. If they have slightly different operating system or a completely different operating system, then the commands might have changed. Okay, so I would recommend looking at the manual for that particular model before you make all the configuration. For number two, it says, in Cisco routers and switches, which mode allows setting changes but cannot be used for configuration? How do you access such mode? So this is the second mode, right? Privilege exec mode. This allows you to enable the exec mode by typing in enable, the word, right? So you're going to use enable command. And we can also type a shortened command like en, which is short for enable. And so the privilege exec mode is accessed when you type in enable in the user exec mode. So that's going to open up the next level for you, which gives you the privilege. So we can modify some settings. Okay. But we cannot fully configure. So if I want to add an IP address, I turn on my router, I type in enable. That's going to take me to the privilege mode. Then from the privilege mode, I type in config term. And then after that, I would get into the specific interface. So on the device, you would see that each point of connection is an interface. So for example, I'm using Ethernet connection, then I want to use that interface for configuration. If I'm using coaxial for that connection for the device, then I want to put in coaxial for that interface. So each of the interface on how the cable is connected to your device, that port configuration is then considered as your interface. Okay, we'll see a little bit more when we have packet tracer practice. Any question? Okay, so the first mode you see is the user mode. Then we see the privilege mode by typing in enable. Then we can go to the global configuration mode by typing in config term. So if you want to modify anything, you have to get to the third mode. Okay. All right. Okay. So for number three, it says describe the purpose of the user exec mode in Cisco CLI. CLI stands for command line interface. So the user exec mode is used to view device settings. So if I want to look at the specifications of the device, like how many ports does it have? And each port, how is it used for connection? Like, is it all 24 ports Ethernet? Or does it have certain ports that would be fiber optics? So the user exec mode is for you to look at the default setting or the settings that already been configured for that particular device. Okay. Or even like looking at the router's name or the switch name. So you can view only in the user exec mode. That's the first mode that you see. Yes. Yeah, maybe the keyboard connection is. So go back and resave and then you go edit. It won't let you modify anything until you do that for each document. Any question? No question? Okay. So when we go through and we modify the name of the system, right? You saw some of this when we did command line last time. We can use host name, and this is because it's embedded Linux. It uses very similar to Linux command. So if we want to change the name of the router, let's say that I want to call it router 1 or router 10, right? What we would do is we would use a command called host name, and we would add in the name of the router or the switch that we want, right? Because out of the box, it's just going to say router or switch. Okay. All right. So in the next question, it says, how do you change the name for your Cisco router to Site1R1 in the CLI? So we need to, first, when we turn on the router, we need to access the global configuration mode. That means that we're going to type in enable. Then after that, we're going to type in config term. Then after that, we are going to use the actual command, which is host name, and then the actual name that we want to give it, which is Site1R1. Site1 router 1. Okay, so those are the steps. Enable, config term, and hostname Site1R1. So 3 steps. And then at this point, if I type exit, it's going to take me back to the user exec mode. And then it would show Site1R1 with the arrow next to it, right? Instead of the router, right? Because now it has a new name. So this is how you can rename your device or change the host name of the appliance. Now, in order to connect your system to the device, right, we would use an application that allows us to have SSH or Telnet connection. I prefer to use PuTTY, but if there might be other ways you can directly use command prompt or command line to do SSH connection, but PuTTY just a little bit easier to interface. There are other programs that you can use, but PuTTY is a common one that you see in the industry. So you would be able to connect your laptop or your desktop or your computer in any form as long as you can run that application and have cable connection. Any question regarding renaming your device? Okay, so let's talk about your media. Okay, I know that we went over this before about the speed. I want to review this because in the next few weeks, you are going to work with different appliances and you have to know the speed, right? For each of the interface. So when you turn on a switch and it tells you, 24 ports, and it would say F0/1, F0/2. So that's considered to be Ethernet, right? Ethernet transfer between 0 to 10 megabit per second. Now, most of you at home, right, in your current system is using gigabit Ethernet, which is our current speed. But in an older appliance, some switches or routers still use the older technology. And you see that in businesses because, you might have a segment that they haven't upgraded because upgrading devices costs money, right? And then reconfiguration and management and all of that. So you might see an older connection, an older media, which is Ethernet transfer between 0 to 10 megabit per second. And when you compare that to like a ThickNet or the coaxial cable that we made, the maximum that can go to is 20 megabit per second. I think for if you doing like a download and upload comparison, depending on the type of service package that you have. So if you have like synchronous DSL, your upload and download is the same. But if you have asynchronous DSL, then your upload and download is different. Your download tends to be faster than your upload. But normally you would see that coaxial is going to be about double the speed, right? Even though coaxial been around a lot longer, right? However, it's just, for the way that we have upgraded coaxial to transfer at copper is that speed. Your fast Ethernet transfer is going to be 100 megabit per second. And this is standard for many years until recently that we have gone to the gigabit Ethernet, which transfer up to 1,000 megabit per second, which is very fast, right? So if you want higher throughput, you want to make sure that your port is at least gigabit Ethernet. But what if the appliance doesn't have it, right? Then we have to upgrade the appliance and making sure that our cable connection and everything else is adequate for that particular speed. It's kind of like, when you have a car, you want to upgrade the motor for your car, you're going to make sure that your motor fits. Or if you want to make sure that you upgrade your tires and rims for your car, right? Make sure that the proper sizes are in place. So technology is the same way. We want to make sure that if the ports, we want to go with the faster port, we want to make sure that the appliance, right? And then is that adequate in our network, and is it going to be supported? Okay. So we can't just throw appliance in there without thinking about the redesign and how the upgrade is going to change the aspect of the overall throughput for our network. Okay. So back to this. Fast Ethernet, right? Serial, you would see this. This is very old technology, but it's been around for a long time. Serial, right? 1-to-1. It's going to be like 1 bit at a time. This is for channel services, for data services. Let me show you what the serial cable looks like. Okay, so technology has changed quite a bit on how you connect your device. When you connect directly to the Cisco device, these are configuration cables, right? They look like your regular cables, but these blue cables, so the configuration cables, sometimes they're black. They come in various types. So the current type that you see is one end is going to be Ethernet, and the other end is going to be USB-A like this, okay? The new ones are USB-C, which is faster and more reliable, and then Ethernet. So this is going to go to your computer, right? Does that make sense for data? The USB connection. And this, the Ethernet end, is going to go into your switch or your router, okay? Now, the older technology, and I can pass this around in a little bit. So Cisco used to charge $50 a cable for the configuration that you get. Amazon cables made in China, that's probably really cheap. But make sure that you read the reviews because not all cables are rated the same, right? We all know that. So similarly, you do see that these cable, they tend to come in blue or like a hue blue. Right? So on the serial, if you're familiar with like serial cable or like the connector from like A+ class. So when I buy a serial, it's usually for like an old switch. Let's say you go to a thrift store and you found a Cisco switch that's really cheap, like $5. And then you look, okay, look at the configuration cable. So if it looks like the old monitor connection, so these are the D connector, right? They look like your old monitor connection. It has two screw on the side like this. This is a serial connection, okay? Slower and for older technology. And then so this, if I have this, and my computer doesn't have it, I have to have an adapter, okay? So you can find an adapter for a few dollars on Amazon. You can have an adapter for serial to USB-A or other form of USB, you can find it. And then this is going to go to the appliance. So the Ethernet end is always going to go to the appliance, and then the other end is going to go to your computer. However, remember that this is slower than this. Right? And the universal serial bus is pretty common for all computer has it. So it's probably better that you find a device or a cable that's going to be adaptable to your computer. So if you buy the USB-C, it is faster, but make sure that you have that safety. And then I can show you that one. Now, one thing that I want to point out, right? When you buy these cables, there's instructions for you to download the driver for it, right? It sounds great. You can spend $15 on the cable, but guess what, right? Sometimes it doesn't work because if your computer is not able to load the driver, your cable doesn't work, okay? So, for example, like the StarTech, it has a special chip in here that converts the signal from your Ethernet into a USB signal, right? So that way, whatever the command that you type on your computer, your device is going to be able to receive it. So before that, when you connect the cable, it's not like your regular USB cable where it's just plug and play. You have to make sure that you look at the website and then load the driver, okay? So I got to prep the IT team and making sure that they do that because every time I do that lab, I always run into a problem that the driver is installed, but sometimes that they disable it for privilege purposes. So you would see that it would say configuration cable USB to RJ45, which is the connector for the Ethernet. And if your switch or device use that, then that's what you plug. So this goes to the device, and the USB goes to the computer, and that's how we set up the terminal for connection, so we can use the commands. Okay. All right, so we touch a little bit on the serial, and then let's talk about the interface. So after you get into the configuration mode, now you want to narrow down on the port of the device, right? I want to configure that particular connection for my switch or my router. For your Cisco switch, okay, I'm going to stand in the front because I don't want to wheel that whole entire thing. When you look at the back, it would say console. That's where your Ethernet connection is going to go. right? Next to the power cable. That's gonna be receiving the commands. In the front, you're gonna see the ports. This is a 48 port switch. This is a layer 4 switch. So for each of these, it's gonna be represented with your interface and a number with a slash, like 10/0 or F0/0, F2/0. So when you're looking at the actual port, right? Let's say that I want to configure a certain fast Ethernet. So this is stand for fast Ethernet. Sometimes it is shortened a little bit different. So we'll say fast Ethernet 0/0. That's going to be the first port, right, in the front. The first port in the front for the switch. Okay? So if you want to go further, it will just be the value, right, like F2/0, which is the third one. Okay? So we have to kind of get used to how it looked at the interface. Okay, so here that will be your fast Ethernet. Now, if I'm using Ethernet, it will be ETH 0/0, right? I have students misconfigure ports all the time because they type this in wrong, right? And then they're getting an error and they're like, well, I'm trying to configure this port, but it's not receiving my command. You have to make sure that the port that you're using exists, right? Is it fast Ethernet? Is it Ethernet? Is that port available, right? So you simply put in an interface and then the type of interface and the number of that interface, okay? It's really straightforward. Take a little bit of practice. F0/1 for the next interface. Okay, so let's go through a little bit of like a simple manual exercise. We're going to configure some of the information for our router. First, we're going to type in an IP address and its subnet mask. So you don't have to put in the subnet mask. Ideally, you should, right? By practice, you would say IP address. Remember that it is embedded Linux, so Linux command is the same, right? IP address, and then the IP address that you want to give it, plus you, and then the subnet mask of that IP address. Okay, so before we get here, we need to do enable config term, right? And then we need to make sure that we get into the interface like what we've seen in the notes. We would say interface F0/0, and then we would give that an IP address. And then if you want to add in description for your particular device, like you can say, region 1, HQ, in this case, I want to put in the description district local area network. So we would say description in lowercase, and then whatever text that you want to add to it. And then we want to specify the speed, right? Because you can actually throttle it. Like, let's say that I have fast Ethernet, but I don't want to use the full capacity of the speed. I can make it less by changing the speed. Why would you need to do that? Maybe you need to throttle it to monitor, or, you need to regulate it a little bit. It's kind of like, how they do the detour and putting, drive slower, put a stop sign so everybody slow down, right? But so you can specify the speed that you want that particular port to transfer. And so we simply just type in speed 1000. Okay, let's move this down a little bit. And then we want to specify the transmission. In this case, we're going to do full duplex. It's going to send and receive simultaneously. And then we want to activate that interface. make it work now. So we're going to do a no shutdown. Any questions? Okay, so we learned how to specify the name. We know how to access it, right? And then be able to go in configuration mode. Now, from this question, we know how to put in an IP address because you will be doing this for the next few weeks or even after we come back from Thanksgiving, right? And then being able to modify. So this is just a brief thing. There are many other things that you can modify in the device, right? You can set a route, you can enable certain protocol, you can create, set up encryption for authentication, or even add DHCP. Okay, so let's go back here, right? Where did I get this information? Remember that we need to be in the interface in order to set up the IP address, right? When you're in configuration mode, hello, you need to get into the interface. So we have to say which interface that we're configuring. And once that allows you, it's going to say config interface, IF like this. And then you can type in the IP address that you want. If you want to add a subnet mask, you can. Some device will allow you to do a slider. So it will be a slash, and you can do /24 or /8. That would also let the system know that, if whether you're using 255.0.0.0, which is /8, or 255.255.255.0, right? Hello. Okay. Description, and then the speed, and then for the duplex, the full duplex, right? You can normally the default is auto. It can change as needed, but you can specify, and then no shutdown. Okay. So if you want other interface, like a serial interface, you would do something like this. And then we can specify, like, if I want dynamic IP address, an IP address that the server is going to give me, you can just say IP address DHCP, and that's going to allow the device to receive an IP address from DHCP server. So for serial link, you can specify the encapsulation protocol like this, where you would say encapsulation as a command, and then you would use D8 or HDLC. And the other option is going to be point to point. So HDLC stands for High Data Link Control Protocol, and this is proprietary to Cisco only. It allows you to connect to another Cisco device via serial link cable, right? And then if you're using point-to-point protocol, and this is a universal protocol, this is allowing you to support authentication. We previously also used it for like remote access in the past. It allows you to connect equipment that uses point-to-point. So point-to-point, basically you connecting one device to the next, and then the next to the next, and so on. So it's like a daisy chain process. Okay, so for 7, it says, which serial link encapsulation protocol is used to connect Cisco device to another Cisco device using back-to-back serial link? And that's going to be your HDLC protocol. And then the command that we use to enable the interface after the configuration is modified is going to be no shutdown. That just means that we activate that interface. It's going to be used. Now, some of the device with the more modern device, sometimes that you don't use no shutdown, you would need to save the configuration to the RAM. So But no shutdown is common in a lot of the Cisco devices. Okay, the next command that we're going to talk about is going to be the copy running config startup config. So this command is used to store the modify setting to startup configuration for the Cisco. Remember that when I configure, I go into the global configuration mode, right? Let's say that I want to enable DHCP on my switch, okay? And that needs to be activated at the startup or as soon as the device is initiated, is turned on. So after I have modified the configuration, I want to have it stored to the startup, right? The modified configuration to the startup configuration of the device. I would need to use the copy running config. That means that it's going to take whatever that is currently used for running configuration, and it's going to copy it to a different area, which is in a different storage area of the device. Even though it is RAM on your Cisco device, you are still going to take whatever that you're currently configuring and you are going to copy it to a different area because this is a location where it's going to use to be able to pull that information when it turns on, when it start up, right? So because a lot of the students, what I see is they just save it there and then they just expect that it works when they turn it on. It doesn't work that way. You have to make sure that you copy it, right, to a different area of your RAM. Okay. Now, if Cisco configuration is easy, right, there would not be certifications for it, and there would not be people who are trainers, right, certified trainer for Cisco for it. So it just takes practice, just like everything else. Once you do it a few times, it gets easier, and then you'll remember. Okay. All right, so storing configuration, we talked about that. Remember that it's from the temporary memory, and we want to put it into RAM, to permanent memory. Actually, it's part of like the ROM that it reads. Okay, so for segmentation, you can set up different things. Like you can have routers for wireless. You can have private local area network for your internal network. DMZ is usually your public facing servers, like your web server, your DNS, for your anything that you can use for the .com or .net, etc. And then you can also segment for special use with wireless. So this is a way that we can divide up into different areas of our network. Okay. So in the switch, there are features or services that you can use. Number one, address learning. This allows the system to learn the MAC address of all the connected devices. We saw our table last week, right? You saw that whenever that you have a device connecting, it's stored that onto the table. Same concept. It's going to give you all the information of the connected system based on their physical address because the switch uses the physical address to locate the system. The port for connection, basically the physical connection like Ethernet, right? Fast Ethernet, etc. And it puts it into a table. So if I want to filter the MAC on the switch, I simply specify. And this is important for security people, right? Your device, when you plug it in, it works. But anybody can plug any device into your switch. So what you can do is you can MAC filter of all the devices that you allowed on that particular segment. It does take a little bit of work, but ultimately filtering is going to help you reduce risk overall, right? If you ask anyone, they're going to tell you, and you can do the same thing with the wireless router at home or inside, right? We can say that, oh, I only allow these devices. And even if you know my key to my wireless router, you cannot be added, right? So we can properly filter so not anyone can just be physically plugging in their cable or wirelessly connecting to your segment. Yeah. So we basically whitelist what we allow. Okay. All right. So for number 10, describe 2 or 3 types of zone in the network. We can use DMZ. This is known as the demilitarized zone, which contains your public servers, such as your DNS, your SMTP. I have it typed SMTP. Your web, like your HTTP server, and other servers that are public facing. Now, in the demilitarized zone, we want to have proper protection. We still have to implement firewall where it's going to protect these systems and detect any kind of attacks or issues that we would be facing from the external network into our DMZ. Then this is separate than your private local area network or your internal network. So between the DMZ and the private LAN, we want to add another firewall. That's going to allow you, our edge firewall is going to protect, right? So from here to here, we're going to route, okay? So this segment of our network is going to be separated. It's going to have firewall protection. And we're going to have the router that's going to route into our private LAN. And before the router can forward all the traffic, we're going to have another firewall. So the router, the firewall, and then our local area network. And then the DMZ is on the... Now, on the rack, they're all the same rack, right? But we would logically separate them. And then your internal network would use, right, different IP addresses, depending on how you want to isolate a certain segment for departmental use and so on. And then from that, we would connect the wireless connection to our wireless router is going to be connecting to our main switch, right? But with that, we also have a protection there, right? So I would also put in the NIPS, the NIPS, and making sure that I isolate my wireless connection to a different segment. So that way it doesn't mix in with my critical local area network, like servers and systems. So wireless, we can put it into the subzone that's controlled by private LAN access. And then all your access point for your wireless, your APs are connected to the main switch. Or it could be the sub switch. Any question? Okay. So we talked about MAC filtering, how that will be on the switch. And the switch is different than the router. The switch is used internally. Can I use the switch as a router? Yes. If I'm using a layer 4 switch or a higher layer switch, I can implement that as a router and a switch. Okay. Now, for loop avoidance, we can use spanning tree protocol. This is going to allow you to avoid loops. And we established that when you have loops, that takes up bandwidth, right? And sometimes that can cause your network to either slow down or have a lot of error. So we want to make sure that we reduce switch loops, okay? So how can we do that? We would place ports that would be used for the loops into a blocking state. So that way it's not looping, right? Looping is it's going back to itself and it's trying to also send that to everybody. You would have broadcast storm or other things that would be involved in that. Okay. So the action can be performed in frame at the layer 2. Number 1, you might have flood. So floods in frame is when it doesn't know a certain MAC address. It's going to broadcast to everybody. It freaks out, right? It's going to say, who is this, right? Just trying to acknowledge that in all the ports. And when you have that, right, it's going to cause problem in your network. So we don't want floods. Then we also have forwarding. This is where we would forward it to a certain frame for a destination system. So let's say that I'm using the switch on the 3rd port, right, to forward that to maybe the system that will be on the 20th port. So it's going to be a way that one port is going to connect to a different port as a forwarding port, right? So instead of, let's say my 3rd port is empty, I would use that as a forward port connecting to the 24th port, right? So I can do that as a forwarding port. I can also filter on the switch. Okay. So in definition for the spanning tree protocol, this is used for loop avoidance. We would place the ports involving the loops into a blocking state that's going to reduce the looping. And when you have a link that goes down, the loop avoidance protocol will detect that it is down and change it to a secondary pathway from the blocking state into a forwarding state. So it's going to kick it back from the blocking state and it's going to become a forwarding state. And this is how spanning tree protocol works to reduce loop. So ports initially becomes, it gets into a blocking state, but when it goes down, right, it changes from a blocking state into a forwarding state. And then the switch action that can be used in frame, we talked about flood. It sends to all system when a MAC address is not known, right? Like a foreign MAC address that it doesn't recognize, it's not in its table, it's going to say, who is this? But it's going to send it to everyone. And then for the forwarding, it forwards the frame to all the known systems. So all the systems that's been connected, it's going to forward it to that, right? Now, you don't necessarily want it forwarded to everybody. You can. This is one of the feature or the service that you would be allowed for frame in the switch, right? We can set up a port, a specific port for forwarding only, so we can regulate that. Any question? Okay, so you can find all of that information on page 3 at the top, and then it goes into STP. So it tells you here that it takes 52 seconds to change from a blocking state to a forwarding state by default, right? If we don't modify this, by default, it's going to take less than a minute for it to kick it over, but you can always change this value. And there are four states: blocking, listening, learning, and forwarding. So if you want it to learn, it's going to store all the connection to the table. And then we talked about forwarding, and blocking and listening is just, it's still registering all of that information. So it's listening port, it's just going to wait and receive. Okay. And then the updated version is your rapid spanning tree, your RSTP. they removed the learning from this particular upgrade in the protocol. You only have blocking, listening, and forwarding. And similar to what you've seen in STP, but in this case, it actually does the polling process or the voting process. So it is a little bit more intuitive compared to what you've seen in the prior version or the STP. Okay, so when you buy a switch, not all switches are created equal. One, if you want to configure your switch, buy a managed switch. Okay, it must be managed. Okay, that means that you can go in and add and modify and filter and control. An unmanaged switch is what I call a dummy switch. Its job is to forward to the destination. That's all it does, right? It simply is a way that we connect the systems together. You cannot manage this particular switch. You cannot configure it. So you just plug the cable in and it works. Okay. So the smaller switches that you see in the segment, like, you know, in the rows and table like this, a lot of the time they buy the unmanaged switch. The bigger switches is usually a little bit higher in the network design or the layout, where we would connect this whole entire room to a managed switch, right? And then that managed switch is connected to another managed switch, and ultimately to an uplink switch that sends to the router. Okay, so we talked about 12. Let's move this down in case you didn't grab that. 13 is kind of long, but you can summarize this. Okay. Yes. You need 11 as well? Okay, so let's go through a little bit of 13. So in order to compare, right, we talked about STP. So STP uses algorithm to determine that the port is which port is created, which port creates a loop and place it into a blocking state. We established this. This is known as IEEE 802.11 or 802.1D. And you can grab this from the notes. I just copy and paste it over. It takes 52 seconds to go from a blocking state into a forwarding state. And there are 4 states for STP. I should indent this so that way you can see. For RSTP, rapid spanning tree, the standard is different. It's 802.1W. This is an improvement of STP. It's an upgrade. And we only have 3 states: blocking, listening, and forwarding, as we mentioned. And then the alternative port is used for backup link for forwarding. And when the port goes down, it activates the port instead of using voting process in STP. So it just activate that port versus the polling process with STP. Any question? So make sure we know the difference between STP and RSTP for our quiz and exam. And then if you're going for Cisco router and switch or any of the certification like CCNA, you also need to know these things. Right? CCNA has some overlapping knowledge with Network Plus, but CCNA focus a lot more on the proprietary for Cisco technology. but you have to know the universal protocols along with Cisco protocols and how to be able to configure the devices. They didn't discontinue CCNA, they just restructure CCNA, right? So if you have CCNA certification, you can grandfather into the new certifications, and then after, and then continue your learning credits. Or after a few years, then you're going to have to retake the certification again. Any questions? Yes.
What number 13 on the note?
For the 13, sorry, you can refer to page 3. And some of it, yeah, page 3 in the middle. STP and RSTP. Another set of feature that you would see is called port bonding, and this is considered LACP. This is a way that you can link aggregation. You might see that in some of the description when you're buying a switch or looking at its specifications. It simply is a way that you can group the ports together, and then you can use that to accumulate a bandwidth. So I can group, like, let's say 4 ports together to give myself a certain speed for that connectivity. And this allows you to use LACP, which is the protocol for link aggregation. So the example here is if you have a 48 port switch, right? You can have 16 of the ports can be aggregated into a channel, right? If you take 48 divided by 16, right? So you can have various channels. So basically you can group up like a group of 16, and that's going to give you a channel for a certain bandwidth size or length. Okay. Okay, for 14, explain the difference between a managed switch and an unmanaged switch. A managed switch has configuration capability, whereas an unmanaged switch doesn't. That's simple, right? So a managed switch would have some kind of operating system, command line interface, and it's able to understand or receive commands. And in the newer switch, or even the small switch that you're going to use today with Netgear, it is a managed switch, but it uses a graphical user interface application, an application that has the capability for you to go in and configure. Many of the newer switches, even for Cisco devices, it has GUI, but it does also use command line interface as well, right? Because they had learned that many people struggle with issuing the proper command for the configuration, so they have added operating system with GUI capability or UI capability. Okay, let's talk about 15. We're going to go through the list of commands that we are going to set up virtual LAN. Okay, so VLAN is a virtual local area network. We can use this to a connection port. So for example, I'm using port number 4 on my switch for a VLAN connection that allows me to connect, let's say, HR department right? So I would connect a baby switch to that port number 4, and then all of the system on that baby switch. So with that, we need to configure the big switch with the port number 4 connection for the VLAN. You have to set it up, right? You guys know that you're on a VLAN with RCCD district network, right? They allow you to access internet or whatever, but they do monitor it. So simply we would take a port and we would assign it a VLAN connection. So it is an interface, right? So you would start with turning on that switch, type in enable. This brings you to privilege exec mode. To configure, we type in configure terminal, or you can do config term like this. This would take you to global configuration mode. Then you want to access the, remember it asks you to do VLAN 2, right? So we want to access the interface for VLAN. So we would do interface VLAN 2, which is the name of our VLAN. Now, if you already have VLAN 2, right, it won't let you activate that. Or if you already have it, it's just going to go into the interface configuration for it already. But if you don't have it yet, let's say that it's new, right? When you say interface VLAN 2, it's just going to name it VLAN 2 for you. Okay. Then we're going to give it an IP address, and this is going to be, so we would say IP address, and then we want to, because it's for the VLAN 2, it's not just regular IP address, right? This is a virtual IP address. It's an IP address for our virtual local area network, but we would use an IP address that we can manage, right? Let's say that my normal IP address in my private network is 10.0.0.x, okay? And I want my VLAN to be 12. Why? Because it needs to be routed into the virtual local area network. I don't want for them to mix, right? Can I use a 10.0.x? Yes, but I have to properly subnet it. But ultimately, we want to treat it as a separate network, even though physically it's not really connecting like a different network, right? Like you would treat it like a separate network from your own network. So the way that we logically do that is to make the IP address to be routable, route into your network. Okay. And if you use a layer 4 switch, it will do that for you in one appliance. Set up, use a VLAN, and then logically it routes into itself. So, and then you can use security appliance attached to it and control it. So we would set up the IP address, and because this is for your VLAN 2, and then we want to store that, right? We want to activate that interface. So we're going to say no shutdown, and then exit brings you back to the read-only mode. Okay. Now, if we want this to be stored at the startup, what do? Right? Copy running config to startup config, right? Copy running config, startup config. So this should, if you are planning to do networking, right, command lines for Cisco and switches and stuff like that, the basic should come naturally, right? Practice until, it's like, you know, if you don't ride a bike for 10 years, you still know how to pedal a bike if you get on it, right? For me, if I don't configure a switch for 10 years, I still remember some of the basics, right? Because it's important that you remember those things, like enable, config term, you know, those things, the steps to get there. Okay. Any question? So the notes kind of give you some similar example. You can refer to this right here. Now it has additional things like switch port mode access. Okay. So Switch port mode access is going to allow you to access that particular VLAN. Remember that this particular case, it's using interface range. So when you want to do a group of ports, you would do a range, okay? And then the type of connection. So if it's gigabit Ethernet or Ethernet, and then we would say port 11 and 12. Or you can do 11 through 16, for example. That's a range. Okay. So in this, we aggregate port 11 and 12, and then we would place those two onto a VLAN 2. We separate them into a VLAN 2, and then we assign them a channel 5. So with that, you would use the switch port mode access to access the VLAN 2, which contains these 2 ports. And then you're going to activate that as a channel 5. So you do a channel group. Okay. So that's for link aggregation. Yeah, if I hire a Cisco person, I ask them Cisco questions like this. How do you set up VLAN? Give me the commands, right? So you really want them to know. Okay. All right. For the next example, we assign the IP address. So I use this example as your assignment, right? So this one is a VLAN 1, and then the IP address you put in here, no shutdown and exit. Now for the router, if we want to configure it as a default gateway, you just access the configuration mode, and then you would say IP default gateway and then put in the IP. And we always want to use the .1 for the gateway. Yes.
Maybe I missed it, but like in the homework, this is like IP address 2. Like
yeah. So yeah, that's an error. Just take out the 2. Okay. So Brandon asks, I had a typo right here. Remove. I don't know why I put that there. You can always try and find out, right? And packet tracer is just, yeah, it doesn't make sense. Yeah, 2. So refer to this example, right, for your questions. And then for the default gateway, it will be like this. Okay, so that answers number 16, I'm sorry. What is the command to configure the default gateway IP address 112.0.0.1 on a switch? And I'm assuming this is a layer 4 switch, right? So we would say IP default dash gateway and then the IP address that you want, 112.0.0.1. Okay, so power over the Ethernet, I think PoE and PoE plus, I'm sure that you've seen or heard of it before, right? In CIS 25 or another class, or if you haven't, there's this little section on the notes that talks about power that you can typo everywhere. Power that you can use or be sent over the Ethernet, which is PoE. And that is on average about 15.4 watts. And then if you see a device that tells you PoE plus, that's going to be approximately high, about 10 more watts on top of that. So 25.5. Okay. So we can utilize the Ethernet signal or the electrical signal and convert that into power signal. That's going to give you 15.4 for PoE and 25.5 for PoE plus. So if you're looking at the appliance and it has that capability, right? You can attach, you can utilize that as also a small power source or power source distribution to another thing. So your computer, right, it depends on the components that you would see. So if you look at like the type of wattage that you would need, right? Hard drive needs about 12, right? Your LED lights and things need about 1.5 watts, and so on. Okay. Your CPU on average, it's about 90 to 100 watts. Motherboard is like roughly between 60 to about 80 or 90 watts. So, and I'm sure that you've learned about power supply and all of that. So power over the Ethernet gives you a little bit of the wattage, depending on PoE or PoE plus. Okay, so you can find that on page 4. Okay, let's talk a little bit more about VLANs. We're going to revisit this quite a bit. All ports are default VLAN, and default VLAN is different than customized VLAN, right? So you can treat all ports as default VLAN. Now, in the Catalyst or some of the older switches, they would only have dedicated ports, like a certain ports. They only have maybe 2 VLANs or, you know, depending on the type of switch. You can create additional VLANs if you need. And then you can put those into a database where you can tell it that store all your VLAN configuration into the database of the switch. And when you access the VLAN, it's going to give you the VLAN mode like this to be able to access the VLAN database. So for example, if you create VLAN 2 for a marketing department and VLAN 3 for the engineering department, you would start like this. Enable, right? And then you would you would need to do config terms, sorry. And then you would do VLAN database. And then inside the database, we're gonna name it, right? VLAN 2, name marketing. VLAN 3, name engineering, and exit. So that's how you add these 2 VLAN into the database. And then after that, you would go into the interface and configure it. So let's answer these questions. So if we want to create VLAN 4 and name it finance department, we're going to do enable config term. And then VLAN database, VLAN 4, we're going to name it finance department. Now this is not configured yet, right? It's just creating a VLAN called finance department and put it into the VLAN database and then exit. In order to fully configure it, we have to tie the VLAN 4 to an interface, right? So we would say, go back, enable config term, interface VLAN 4, and then we would set the port range for it. So which is what we do next. So enable config term, and we're going to place port number 5 and port number 8 for the VLAN 4. So that means that those physical port 5, 6, 7, 8, I can connect systems or switches or whatever that I need for that finance department, right? On my switch. So I would go into the configuration term. I would say, I messed up. Did you guys catch me? You guys didn't catch me? Interface range. Sorry. Interface range. And then you're going to do fast Ethernet 5 through 8. Okay. And then you would do switch port access VLAN 4. So that means that I'm going to group these 5, 6, 7, 8, the 4 ports for the VLAN 4. So within that, I can connect a small dummy switch and then a bunch of computers onto that switch or other appliances. Like I can put a firewall there for them, or wireless connection, like access point on that particular, but you want to have protection, right? So these are going to be dedicated. Now, we didn't do the aggregation link on this one. So if you want to aggregate the link where you can combine them for a certain bandwidth, so you can actually see how they use their bandwidth, then you can set up your channel for aggregation link. Does that make sense a little bit? Or just words on paper or screen? Okay. When we exit, we want to do show VLAN, and it should list whatever that you had modified, right? Like, boom, it's gonna say, if you have one VLAN, it's gonna say VLAN 4. If you have VLAN 2, VLAN 3, VLAN 4, it's gonna list your VLANs. Okay, so you can use show VLAN to display. Remember, when you exit out of the config mode, you are in read only, and that's just to view configuration. And nobody caught this last time I taught this. Okay. Yeah, see? Interface range. That's what you want. Now, some switch will take it with just the way it's typed like that, but other switches, traditionally you want to put in the range for a group of ports. Okay? So we did like the range for port 2 to 4, that's for VLAN 2, port 9 through 12 for VLAN 3, and then you got to exit for both. You got to exit, you get out of all the mode. And then if I want to see the VLAN, show VLAN, and it's going to list the 2 VLANs that I created, 3 and 2. Okay, let's talk about trunk. Trunking is important. It's old technology, but it's still being used. So a switch can connect to another switch through a connection called trunk ports, right? If you bridge them together, I think in the prior chapter, it talks about that. When you connect a switch to a switch, we call that bridging. And we would use a trunk port. Trunk port can carry VLAN packets from one switch to another. That means that I can set up VLAN on one switch, and VLAN on another switch, and they can communicate, right? How cool is that? So it needs to transfer on a trunk port. So you have to set that up. Okay. Now the protocol that it does this for VLAN tagging. So in my 41 class, I talk about VLAN sprawling, right? Like that means that they can go from one VLAN and they hop into another VLAN. And simply they're able to tag the ID through that. So there are tags now that you can jump from one VLAN to another. So the protocol that's used is your ISL. This allows us to link the switch. This is for Cisco technology for the VLAN, right? It associates the packets through tagging, and it's going to know which VLAN. Now, VLAN trunking protocol, which is your VTP, this is also Cisco proprietary technology. This allows you to use the switch with another switch for VLAN connection, or many switches, I should say. Okay. But by default, you would have the native is going to be equal to default VLAN. So when you configure on some of these switches later on, you're going to see that you can only have the native VLAN, right? It doesn't have the other capability where you can set up trunking or other areas. Okay. But to set up trunk, you would do switch port. Anytime that you configure a port of a switch, you use switch port. And then you say that this is a trunk, and you would use that for the native VLAN 1. And some of them, they would tell you it only has 2 native VLANs. Like you can only do native VLAN 1, native VLAN 2, and that's it, right? And then other switches will allow more, but by default, a lot of the times you only have limited number of native VLANs, okay? But we would tie that to a physical connection. This is port number 12 on the switch, and we're going to trunk that for the native VLAN. Why? Because we're going to use that port to connect to another switch and set up the VLAN on the other switch, right? So that way we have a bunch of VLANs talking, right? We have a network and we would have a bunch of VLANs on it. And that will be useful for like VoIP, you know, departmental use, isolating the network for testing, tons of things. Security. Okay, so for 20, what protocol is used to create a list of VLANs from one switch and transfer that list to another switch? We would use the VLAN trunking protocol, UDP. And the command that we can use to set up the trunk for VLAN 2, we would use switch port because that's for the switch port after we get into the interface, of course. And then we would say that's trunk and the native VLAN that you want, which is VLAN 2. Now, when you turn on the switch, a lot of the time it makes you go through like the setup, creating a password. By default, Cisco technology is going to be lowercase Cisco, right? You can always reset the appliance or re-image or reinstall the iOS. The command that we can use to force login onto a switch is called login local. Okay. Now you can also apply type of encryption that you would use for terminal connection along with authentication on these appliances. So you can set that up initially, okay? And if you don't, you can always go back and configure that. Okay. Port mirroring, I think we touched a little bit on this, right? Port mirroring is very important for monitoring. Basically, you copy all the traffic from one port to another and then monitor the copy port. So let's say that I have port 10 and port 12. Port 10 is receiving a lot of traffic that could be potentially an attack. I take that traffic and copy it to port 12 and then monitor port 12 to make sure that I detect or I can see if it's a certain type of attack, right? Or it could be malware. You can filter the port with the MAC address. You can specify one address per port. Okay, so the login local came from here. Your switch management, you need to use, you have a username and password, right? You can configure that. So in order to set that up, you would go into configuration mode and then you would set up your login local, okay? Now, if I want to specify like telnet connection, which I don't recommend, you can also do line VTY and then 04, which allows you to do telnet ports. And line is just basically for login for the connection to that particular service.
Telnet you don't recommend it's not encrypted, right?
Yeah, it's not encrypted. It's everything is in plain text, so whatever you type, they can see. Yeah, for vulnerability assessment, the first thing that I tell my student to check is to check to see if there's telnet, right? You should disable that so I can scan against your appliances if I'm part of your network, and then I can see if you have telnet. If you have telnet, then I can get telnet connection, because telnet doesn't require a lot of authentication. So I just need, let's say that this switch or the router is an IP address like 10.0.0.2. I just do telnet 10.0.0.2. Boom, I have a connection. And then now I can control your router or switch. Right. But if you have SSH, it requires public key encryption. So that means that they have to authenticate, right? So you can force login and all of that. Okay. So when troubleshooting a layer 3 switch, a layer 4 switch, right? Anything that can route and also apply other layer, right? What should you check? And there you can refer to the troubleshooting section of your note. Make sure that we check for stale or bad missing routes if there are routes that are not effective. So look at the routing table. And also look at wrong subnet mask. So wrong subnet mask would do what? Send you to the wrong area, right? It uses a subnet mask to route. So if you put in the wrong subnet mask, even though if your IP is correct, your computer is not going to care. It looks at the bits that are on in a subnet mask. It's kind of like you send it to the wrong exit, right? You say, okay, you can get to my house from here, but you send them to an exit in a different city. Guess what happens? It will not get there, right? So wrong exit, right? Wrong subnet mask. Wrong gateway. That means that it's definitely on the wrong freeway. So it will never be able to get there. So if you tell me to take the 215, right, but I'm supposed to take the 10 freeway, then I'm definitely not going to get there. Well, maybe I can, but it's going to take a long time, right? So you are going to see wrong gateway issue, okay? If you have a duplicate IP address, that's definitely a conflict. So when you have a conflict, which system is which IP, right? It's not going to be able to distinguish between one to the other system that has a duplicate IP. So make sure that you check that. Wrong DNS, that's definitely going to take you to the wrong network, wrong domain. Okay. So we want to look at the configuration, making sure that we address them, right? So before you deploy the appliances, always test the appliances. You can set up a virtual network or, simulate a physical network in that for those before you roll them out. I highly recommend that. Okay. And then your configuration can be backed up and stored into the database for configuration management database. So in the case that if your device crash or something happens to it, you can, roll back your configuration so you don't have to start from scratch. Because you never know, things happens on networks, right? Like you get ransomware and it start wiping or locking all of those things, your servers and encrypt devices. And so any question? Okay, that's all she wrote. I'm going to stop recording here, give you a break.